Okay, the value of k that you got, that is coming as 30. Now you need to put back that value of k back to that equation number 3. Now the question arises, why I am going to put down the value of k in equation number 3, not in equation number 1 or 2? Because P is the coordinate, P is the point at which curve and the equation of a line are cut at each other. So it means that this is the intersection point of a curve and a straight line. So the equation that I got after doing the comparison, or the after doing each and everything for the intersection line, or a straight line and a curve, the equation that I got, I need to put back the value of k into that, not into the equation number 1 or 2. So the equation that I have from the A part, it was 5x square plus 30x plus 75 minus k, which is equals to 0. Just put back the value of k back to that equation and do simplification. You will get 5x square plus 30x plus 75 minus 30, which is equals to 0. 75 minus 30 would be 45. So it becomes 5x square plus 30x plus 45, which is equals to 0. This is a quadratic equation. So you can solve it because I need to find the coordinates. He is not talking about a single solution or a single value for p. He is talking about coordinates of p. It means that now you will solve by using a quadratic formula or factorization, whatever that is easy for you. You will not apply the discriminant rule over here. Reason? Because I need coordinates, not a single value. So I just simply solve the quadratic equation, and at the end I will get x square plus 6x plus 9, which is equals to 0. I just divide that equation with 5 in order to get the standard way. Now I can make a factor. X square plus, I need to find any two pairs whose sum should become 6 and whose multiplication should becomes 9. So clearly I can choose 3x and 3x. That is equals to 0. First pair and second pair, x plus 3. From the second pair I can get 3 common, x plus 3, which is equals to 0. It means that I have solution x plus 3 whole square, which is equals to 0. I need to find the coordinates, so it means that I can apply the square root on both sides, and that will become x is equals to negative 3. I get the value of x, that is equals to negative 3. Now I need to find y, so I will go back to the equation number 2 to put back a value of x over here and figure out the value of y. So that becomes x plus 5 is equals to y. The value of x is negative 3. So negative 3 plus 5, which is equals to y, and y is equals to 2. So the points or the coordinates for p would be negative 3 and 5. That's my answer. Next is question number 8. An arithmetic progression is such that its first term is 6 and its 10th term is 19.5. Find the sum of first 100 terms of that arithmetic progression. This is a question of arithmetic progression. So first of all, recall the formula that you people used during the syllabus covering of arithmetic progression, sum of arithmetic progression and sum of geometric progression. The formula was Sn is equals to n by 2 times by 2a plus n minus 1 times by d. This is the most common and most important step you should remember once you are able to find the sum of some terms of arithmetic progression. That formula will be used for it. Now figure out what are the values that are given to you in the question. The things that are given to you: nth term, it means that your n is 100 and the first term is 6. First term is basically your a, and 10th term is 19.5 I meant. So that is your a10. The thing that is missing is d. First of all, you must need to find the value of d. Without that, you are unable to find it. So let's plug back the values that are already known to you. As 100, which is equals to n is again 100 over 2, 2 times of 6, the value of a, plus n is again 100, 100 minus 1, and d is unknown. I don't know how much the d could be. I need to find d first. In order to find d, I will use the nth term formula again, that is an is equals to a plus n minus 1 times by d. We are talking about first to 10th term, so it would become a10, which is equals to the value of a1, or you can say the first term, that is 6, plus 10 minus 1 times by d. 10th term value is given to me, that is 19.5. So 19.5 is equals to 6 plus 90. I will shift 6 on to the other side. It would become 19.5 negative 6, which is equals to 90. I need to find d, so I will divide 9 onto the other side after taking away 6 from 19.5. So 19.5 negative 6 will become 13.5 whole dividing by 9, which is equals to d, and my difference of two consecutive terms is coming as 1.5. So that is my d. I just go back and plug back the value. That will become 100 over 2 times by 6 times by 2 is 12, plus 100 minus 1. Sorry, I think so there should be 10, not 100. Yeah, there should be. There are first 100 terms. No, that's fine, because we are talking about 100 terms, so there should be 100. Okay. So 2 times 6 is 12, and 100 minus 1 is 99, and d is coming as 1.5. Yes. Now solve it. 50 times by 12 plus 19 times 1.5 is coming as 148.5, and that will become 50 times by 12, or you can just add up the terms and then multiply. That would become 50 times by 12 plus 148.5 is coming as 160.5. 160.5 times by 50, that is coming as 8025. That's your answer. Okay, next is geometric progression a1, a2, a3 up to so on of some terms is such that a1 is 24 and common ratio is 1 by 2. The sum of infinity to that geometric progression is denoted by s. The sum of infinity to even number is denoted by se. Find out the value of s and se. If you carefully look at the question, this is somehow tricky. In that question, author needs to find two things. First one is sum of infinite terms that contains even, odd, all of the terms. And the other part contains the sum of infinite terms, but these terms should be even in nature. So you need to find two things here. First of all, I need to find s, that is denoted by sum of infinity. So s infinity, this is a question of geometric progression, so definitely you need to find the you need to apply the formula of infinite geometric progression, not arithmetic progression. Geometric progression s infinity could be written as a over 1 minus r. R is the common ratio and a is the first term. Just look at that. A1 is your 25 and common ratio is 1/2. So it means that you can write the things in the formula. That would be 24 over 1 minus r is coming as 1 by 2. Is that? Once you apply the things and simplify, you are able to get 24 remain as it is, and in the denominator it's 1 by 2. Solve it. 24 times by 2, that is coming as 48. 48 is the sum of infinite terms, that is your S actually. So you can write S is equals to 48. Second thing that you need to find is SE, infinite terms of the geometric progression, but these terms should be even in nature. So SE you need to find. Definitely same formula will be used, but in somehow ratio will be changed for it. Write down the expression of SE first. SE contains A2 plus A4 plus A6 plus A8 plus so on, all the even terms that are even in nature. A2 could be written as A1 was talking to B, if you remember, geometric progression formula, general nature, it was An is equals to A times R raised to the power n minus 1. I need to find A2. So for A2 I need to write, for A2 I will write A2 is equals to A R raised to the power 2 minus 1, that is coming as A times R. This is the value of A2. I have the value of A, I have the value of R, right? So similarly, A4, A6, A8, all these things would be able to apply by using the same formula. So the value of A2, at the place of A2 I can write AR plus 4 will be reduced to A times R cube, 6 would be reduced to A times R5, and 8 would be reduced to A times R7 by using the same scenario that I did here, plus so on. A is common in everything, so I can take A common. A could be taken outside. R plus R cube plus R5 plus R7 plus so on. Now the value of A is coming as the first term value, that is 24. So at the place of A I can write down 24. What could be the R? R would be the common ratio. That is already known to me. It is 1/2. So I can write 1/2 plus 1/2 cube plus 1/2 5 plus 1/2, sorry, here is 2 raised to the power 7 plus so on. Once I solve it, I'm able to get the answer. So after doing the solution, I will get 24 times by 1/2 plus 1 by 2 cube plus 1 by 2 5 plus 1 by 2 7. So I can write 24 times by, the value of A is coming as, I meant the common ratio, that is 1/2 over 1 minus 1 by 2. That is coming as further 24 times by 1/2 times by, once I take the LCM and then substitute the values, I will get 4 by, this is 1/2 and 1/2 square, I think so, here should be square, yeah. So it be 4 by 2. Once I solve it, I will get 16. So 16 will be the answer for that. I hope so I meant it clear. You might have problem in finding the R for it because R is the common ratio. Once I solve the rth positions over here, actually I was doing, I'm talking about this step, the value of R. The R is coming as 1/2 plus 1/8 plus 1. 2 raised to the power 5 is coming as 32 and so on. And the common ratio, I am able to apply the common ratio R. For the even terms it would be 1 by 8 over 1 by 2. Once I do that, 1 by 8 over 1 by 2, my answer was coming as 1 by 4. That's why instead of using r as 1 by 2, the common ratio for even term is coming as 1 by 4. So that's why instead of 1 by 2, the common ratio value I was using as 1 by 2, 1 by 4 actually. In that way I did that. I hope so I meant it clear. So that was all about a geometric progression.